Okay, good morning to all of you. Whether the slide is visible, please anyone respond. Hello.
Yes, sir.
Yes, sir.
Okay. Okay. So I'm sorry because joining late, there is some network issues in the campus. I do not know how much time we can continue, but you just see if sometimes I'm not audible or visible. Just please let me know. I don't know how much time will continue from the morning. Huge disturbance on the net. Okay. So now let's see. Another type of what this black box testing, that is positive testing and negative testing. Last class we have discussed orthogonal testing. So this is a simple easy technique. We will go fast because net sometimes may go. Now, first we'll see positive testing, then we'll see negative testing. So let's see what is the objective of positive testing. Positive testing tries to prove that a given product does what it's supposed to do. So that means what you have written in the SRS document, what the system should supposed to do, whether that system is doing the same thing or not, that can be what proved by positive testing. Suppose in library system, you want to test that while issuing a book, the maximum number of books a student can take is 3. So you will see that, you will try to see that whether the system is allowing you to up to 3 books or not. So positive testing, it tries to prove that a given product does what it is exactly supposed to do. This positive testing is the testing process where the system is validated against the valid input data. You have to give only valid input data. Suppose the maximum number is 3 maximum books you can take is 3. So you should give what are the valid data 1, 2, 3. You should not give less than 1, that is 0, or more than 3. You have to give only valid input data. In this testing, the tester always checks for what? He checks for only valid set of values. What are the valid set of values? As in my previous example, I have told maximum 3 books you can take. So valid set of values are 1, 2, 3. And the tester, he checks that if an application behaves as expected with his expected inputs. So whatever the expected inputs, if you are giving, the system is behaving properly as expected. This is tested using positive testing. Now, let's see what is the intention of this testing. The main intention of positive testing is to check whether the software application is not showing error when not supposed to and showing error when supposed to. I'm saying again, we are doing only valid, we are testing with the valid input test data. So what we will do, we'll try with the part tech, say, in when you are giving some what outside range some data, invalid data, then it should show some error message, and when you are giving valid data, it should not show an error message. So the objective of positive testing is that you should check whether the software is showing error when it is supposed to do, for which input value it should supposed to show error message it should show, and for which input error for which input values it should not show what any error. So for those values it should not show, actually it is not showing. That is what is tested in positive testing. So such testing is to be carried out keeping positive point of view and only execute the positive scenario. So this type of positive testing, it has to be carried out keeping positive point of view. You have to only consider positive aspects, keeping positive point of view, and you have to only execute the positive scenarios. You should not consider about the negative scenario, the invalid part inputs. When a test case verifies the requirements of the product with a set of expected output, it is called positive test case. Okay. So when a test case, it verifies what? It verifies the requirements of the product. The requirements mentioned in the SRS document with a set of expected output. This output you are expecting, it is called positive test case. So normally you are taking only valid input while performing positive testing. The purpose of positive testing is to prove that The product works as per specification and expectations. Okay, it works what? It works as per the specification and expectations. What is mentioned in the SRS document, for which input how you should behave, what should the expected result, the software should behave like that only. So the purpose of positive testing is to prove that the product works as per the specification and expectations. A product delivering an error when it is expected to give an error is also part of positive testing. See, you don't think that it is showing error or means it is not behaving properly. No, if for some say outside the range, it should give, actually it is giving, then it is correct. So a product which delivers an error when it is supposed to give, expected to give an error for some specific inputs, this is also a part of positive testing. Positive testing can thus be said to the products for positive requirement in the SRS document. How you have meant for actually for which input values it should give errors or it should give warning messages. If it is doing in that way, then we say that yes, we are successfully conducted positive testing. So positive testing can thus be said to check the product's behavior for positive as well as negative conditions stated in the requirement. Say that only what conditions. We have to also take some negative conditions, just like in equivalence partitioning, we are taking some valid as well as invalid data. Similarly, here also we have to take some invalid data and we have to see how the system is behaving. This is also a part of positive testing. Now let's quickly see some of the examples of positive testing. Let us consider a scenario where you want to test an application which contains a simple text box. To enter the age and the requirements say that it should take only integer values. Suppose you are applying some application for some job. You have to apply the age field and age should be an integer. So here what positive testing you should carry? So we have to provide only positive integer values to check whether it is working as expected or not. It is called as positive testing. For example, say in the bar I have written 999. It is only a number. I cannot write the ABC. So then this is a positive. Most of the applications developers, they implement positive scenarios where testers get less defects count around positive testing. So around the positive testing, if you will do the test cases, if you will design the test cases properly, you will get, if the developers have properly developed the software, the applications by implementing positive scenarios, then the testers will definitely get less defect counts around positive testing. So this is a positive testing where for age testing will take more larger examples. Let us quickly take another example. So let us take a lock, and we do not know how the levers in the lock work, but we know only we only know the setup inputs. Okay, how inside the lock is working, that we do not know. We only know the inputs like this specific sequence of it and the direction of turn of its key and what is the expected outcome, that whether it is logged or unlocked like this. For example, if a key is turned clockwise, it should be unlocked, and if it turned anti-clockwise, it should be logged. Okay, now to use the lock, one need not understand how they work, because see, I am discussing black box testing. How the internal lock working, I do not know. How the levers work, that I do not know. So I am conducting black box to use the lock, to understand how they work. However, it is essential to know the actual lock and functionality of the lock. That you should know. Some of the functionality that you need to know to use the lock are given in the next table. I am audible. The slide is visible. Please respond in between. Yes, anyone? Hello? Parvanand?
Yes, sir.
Hello? Okay. It's visible. Okay. because I do not know whether net will go. So if you have any problem, you just call, or you can call to my mobile if any problem. So now let's see. I have taken a simple lock exam. Then what we are doing? So we are doing this. We have to now explain for this lock example what are the functionalities, and based on the functionality we have to design the test cases. Okay. Now some functionalities to use the lock are as follows. Maybe one functionality, what should the features of a lock? It is made of metal and it has a hole for provision to lock like this. What are the features of the key? It is also made of metal created to fit into a particular lock's keyhole, etc. Actions performed. What actions you can take? You have to go insert the key and turn it clockwise to unlock. Then you have to insert the key and you have to turn anti-clockwise to lock. What are the different states? Like states is one state is it is locked, other state is unlocked. So two possible states. Either the lock is in locked state or unlocked state. What are the inputs? Only key. The key has to be turned clockwise or anti-clockwise. What are the expected output? Either it will be locked or it will be unlocked. So expected outcome is locking and unlocking. Okay, please wait for 1 minute. There's some sound. Okay, sorry for the interruption. Some sound was coming. I had gone to stop them. Now, am I audible? Yes, please respond. Manot?
Yes, sir.
Andrila?
Yes, sir.
Okay. So now I have mentioned some of the functionalities of the lock. Now we have to see based on this these functionalities, how to design black box test cases using positive testing. Okay. Now, as I have already told, these are some of the functionalities, like what are the features of the lock, features of the key, what actions you can perform. The possible states are there are two possible states. Lock. Input is only key, either turning with clockwise or anti-clockwise. The possible expected outcomes are also two, whether you are locking or it is unlocking. Now this is a part of the requirement specification SRS document. So some sample requirements for the lock and key system is given. Like a requirement, every requirement must be having unique identifier. So description is that you are inserting the key, which key number is 1, 2, 3, 4, 5, 6, and you are turning it, and it's facility locking. When you are making clock, it should be what facility locking, and its priority should be locked. Second requirement is you are inserting the key number, same key 1, 2, 3, 4, 5, 6, and you are turning it anti-clockwise. Then anti-clockwise means it should be unlocked. So priority is high. Requirement is only key number is this 1, 2, 3, 4, 5, 6, and it can be used to lock and unlock. Another requirement, no other object can be used to lock. Only that means only key has to be used to lock. No other, like hairpin or something stick or something. No other object can be used to unlock. Another requirement is lock must not open even when it is hit with a heavy object. So somebody you are putting with a hammer, it should not unlock or it should not open. The lock and key must be made up of metal and must weigh approximately 150 grams. Okay. And similarly, lock and unlock directions should be changeable for usability of left-handers. So if there is a lefty, then this direction should be changed like this. So some of the requirements we have identified, and because unless you are having requirements, I will perform this black box testing. So from the SRS document, find out the requirements, then you will perform black box testing using positive testing. Very simple example. Now I have taken some of the positive test cases, design some of the positive test cases. So I have already told you every test case must have some ID. So first test case TC1. It is corresponding to which requirement? BR01. What is BR01? That you have to insert a key and you have to turn it clockwise. What is the input to this? Key. And what is the key number? Key number is 1, 2, 3, 4, 5, 6. What is any second input? Yes. The clock has to be clockwise. You see, I have written in the document, SRS document, turn it clockwise. So direction is clockwise. What is the current state? In the current state, it is unlocked. And to the output, when you are entering this key 1, 2, 3, 4, 5, 6 and turning it clockwise, the expected output should be logged. From unlocked state, it should change to logged state. So my test case contains what? The inputs. Here the inputs are input 1, input 2, and the current and output is what? Expected output, whether logged or unlocked. Test case 2, requirement number BR01 and key is same, and we are what we are supposed to turning clockwise. It is in already logged state, and we are entering a key and again we are turning clockwise. So what will happen? Already logged. So no state. Another one BR02, say we are turning anti-clockwise, but current state is, so what we are expecting should be no change, because you are taking anti-clockwise, the key will be unlocked. Since it is already unlocked, no change. Another test case, same key, you are turning anti-clockwise, but the current state is locked. Then obviously, if you are in locked state, you are turning anti-clockwise, the expected output must be unlocked. And similarly, another requirement BR04. 04 says what? No other object can be used to log. Only what? The key. Somebody has insert a hairpin or a stick or some other thing, and you are turning clockwise. So current state is logged. You should not change its state. So no change in the state. Like this, you can add so many test cases for each of the requirements. I have left as assignment for you. So in this way, see, I have taken a simple clock and I am performing. These are all positive cases. See, even if there is no change, this is a part of positive test case. So don't consider these are negative test cases. We know when the clock is in lock state and still we are entering the key clockwise, there should not be any change. So whether we are getting this thing as output or not, so this is a part of positive testing. So if you are not getting the expected output, suppose you are developing an automated system for this. So if you are not getting the expected output as mentioned in this table, then some problem in your system. Okay. So in this way, you can design positive test cases. So now, as I have already told you, in positive testing, there can be two conditions: positive test condition as well as negative test condition. So now let's see the example of positive test condition for positive testing. You take the first row in the table. So in the first row, what is there? In the first row, when the lock is in an unlocked state and you are using the key and you are turning it clockwise, the expected outcome is to get it locked, isn't it? You are taking the key, current state is unlocked, you are moving clockwise. What is the expected output? It should be locked. So this is a what? Positive condition. So during the test execution, if the test results in locking, you say that yes, from unlock to we are moving to lock, then the test case is passed. Now let's take an example of negative test condition. I have already told you positive testing includes two things: positive test condition and negative test condition. Now you go to, let's say, fifth row table. Fifth row. 1, 2, 3, 4, fifth. So fifth row, what is happening? That the lock is in already locked state, and you are using a hairpin and turning it twice. Then what should happen? It should not cause a change in state or cause any damage to the lock. On the test execution, if there are no changes, then the positive test case is passed, isn't it? Here you can say this is what you can say, this is a negative condition, because what is you are taking the object, you are taking a hairpin, and the hairpin should not change the state of the lock. It is, if it is locked means it will change in lock state. If it is unlocked means it will remain in the unlocked state. There should be no change. So this is an example of what? This is an example of negative condition in the positive testing. Okay. On test execution, if there are no changes, then the positive test case is passed. So this is about positive testing. Let's quickly look at the negative testing. So this is just opposite of the positive testing. Negative testing is done to what? It is done to show that the product does not fail when an unexpected input is given. Your objective is you are giving an unexpected input. Try to give, and then actually the objective is the negative testing is done to show that the product does not fail when an unexpected input is given. When you are giving an unexpected input, the product does not fail. The purpose of negative testing is to try and break the system. So what is your objective? Deliberately give unexpected input and try to break the system. So the purpose of negative testing is to try and break the system. Negative testing covers scenarios for which the product is not designed and coded. So you are not designed the product for this particular values. You deliberately test with that one. For example, you are that example as I was saying, it's designing for only what? Integers. You deliberately put an alphabet. See how the system is behaving, whether proper error message is giving or not, like that. So negative testing covers scenarios for which the product is not designed and coded. Deliberately you give those types of input values for which your system is not designed. In other words, the input values that you are supplying to your system may not have been represented in the specification of the product. In the SRS document, those input values are not mentioned. The system should not actually accept those input values. These test conditions can be termed as unknown conditions for the product as far as the specifications are concerned. Okay, so these test conditions, they can be termed as the unknown conditions for the product. These test conditions may be termed as the unknown conditions for the product as far as the specifications in the SRS document are concerned. But at the end user level, there are multiple scenarios which are encountered and that need to be taken care of by the product. It becomes even more important for the tester to know the negative situations that may occur at the end user level. Okay, for the tester, he has to know what are the negative situations that may occur at the end user level, so that the application can be tested and made foolproof. Okay, so it becomes even more important for the tester to know the negative situations that may occur at the end user level, so that the application can be tested and it can be made foolproof. Now let us summarize. A negative test case would be a product, or a negative test would be a product not delivering an error when it should, or delivering an error when it should not. Please recall with this what positive testing, what I was saying. Please see how does it differ. In positive testing, I'm saying here, in positive testing, what we are supposed to do? We are checking that whether the software application is not showing error when it's not supposed to show, and it is showing an error when it is supposed to show the error. But in negative testing, just the reverse. In negative testing, what we are supposed to do? A negative test case would be a product which is not delivering an error when it should. That means it should show an error at this time, but it is not delivering that error. Similarly, or delivering an error when it should not. Right now, for this input value, it should not show an error, but it is delivering. So those kind of test cases you should design. So a negative test case would be a product not delivering an error when it should deliver, or delivering an error when it should not deliver. Okay. Negative testing is the testing process where the system is validated against what? Against invalid input data. But in positive testing, it is validated against valid input data. Okay, so negative testing is the testing process where the system is validated against invalid input data. A negative test checks if an application behaves as expected with its negative inputs, give some negative inputs. A negative test checks if an application behaves as expected with its negative inputs. And the last bullet I have already explained. The major objective of negative testing is to check whether the software is not showing an error when supposed to show and showing an error when it is not supposed to show. Such testing is to be carried out keeping negative point of view. In positive testing, the testing is carried out in keeping positive point of view. But in negative testing, such testings are such testing is carried out. Such testing is to be carried out by keeping negative point of view and only executing the test cases for only invalid set of input data. We do not give valid set of input data. Valid set of input data we give in positive testing. Here we give invalid set of input data. Negative testing is a testing process to identify what? To identify negative testing is a testing process to identify the inputs where the system is not designed or unhandled inputs by providing different invalid inputs. Okay. So negative testing is a testing process to identify the inputs where the software system or where the application, where the system is not designed, or it is a testing process to identify the unhandled inputs, the inputs which cannot be handled. Deliberately we will give those inputs or unhandled inputs by providing different invalid inputs. Okay. The main reason behind negative testing is to check the stability of the software application against influences of different variety of incorrect validation data set. Deliberately you give incorrect data set, see whether your software is still able or it is still stable or it is some problem. Suppose sometimes you are giving age the negative value, whether this software is failed or it is actually giving what error message, sorry, you have given a invalid input, those type of warning message is giving, or it is simply failed. So that is the objective of performing negative testing. Negative testing also helps improve the testing coverage of the software under test. So the software you are testing, so negative testing will help you to improve the testing coverage of the software that is under test. Both positive and negative testing approaches, they are equally important for making your application more reliable and stable. Don't think that only positive testing is required. Also negative testing is very much required, and to make your system foolproof, to verify that your system is stable under or when you are supplying invalid data sets. Okay. Now let's quickly take the same examples. So I am taking again this age example. So here what we have to do, I have already told you it should accept only integer values. So here in negative testing, what you give? You give any other value than integer value. So here provide a characters value, suppose like ABCD in the age text box, and check the behavior of the application. Deliberately you will give all other values excepting integer value. And either it's then, what should you expect? Either the software should show a validation error message for all invalid inputs. Okay, that means for all values other than integer values, or the system should not allow to enter a non-integer values. Either you will design in such a way that it should give an warning message or error message, or even if you will type A, it will not be entered. So those kind of things you should see. The system is not moving. You are not able to type any value other than integer, like example. Now I am taking this same example, that key example, lock and key. So one test case is like this. You are using some other locks key, not 1, 2, 3, 4, 5, 6. I am using 7, 8, 9. So any other key for the lock. Some other locks key, turn input to which you are turning clockwise. So what should happen? Current state is lock, expected output is also lock, because you are using some other locks key. Again, if you are using some other lock key, you are turning anti-clockwise. If the current state is unlocked, means expected output should be unlocked. But if you are opening with some other key, many times people do, they make some duplicate key or say some other key, they hit and they trial and it is opening. That means some problem in your lock. So those things we are testing to making our system more stable. So if you are using some other locks key, you are turning the key anti-clockwise, the state should not change. If it is in current state is unlocked, it should be also the expected output is also unlocked. Similarly, if you are using a thin piece of wire or a whether you are turning anti-clockwise or okay, if you are turning anti-clockwise, then also there should not be any change in state. If you are hitting with a stone or hitting with a hammer, still then the current state should not change. It is locked. It should not be unlocked. Expected output also it should be locked. Okay. So in this way, we can design the negative test cases for the locking system. In this above table, there are no required numbers. This is because negative testing focuses on what? Test conditions that lie outside the specifications. So that's why you have not given the requirement number here, because it is used to, in the above table, there are no requirement numbers. This is because negative testing focuses on, it focuses on testing the conditions that lie outside the specification. That's why you have not used the requirement number. Since all the test conditions are outside the specification, they cannot be categorized as positive and negative test conditions. Just in the positive testing, I have taken two conditions: positive test condition, negative test conditions. But that is not required because the input conditions, the test conditions, they are all outside the specifications. Okay. Some people consider all of them as negative test conditions, which is technically correct. So they may say that, okay, these are all negative test conditions. Some people assume, okay, that is also correct. So the positive and negative test scenarios, if the requirement is saying that password text field should be accept 6 to 20. There's another example. You are entering the password, login password, and the password should be 6 to 20 characters and only alphanumeric characters. The positive test scenarios and negative test scenarios written, these are very easy. So positive test scenarios could be like password text box should accept only 6 characters. Password text box should be allowing up to 20 characters, and the text box should accept any value in between 6 to 20. The text box should accept all numeric and alphabet values. Okay. And what could be some negative test examples? Password should not accept less than 6 characters. So deliberately you give what? Deliberately you give less than 6 characters. Then the system should not accept or should give error message. Similarly, in the password text box, you deliberately put more than 20 characters. Either the system should not allow or it should give error message. Password text box should not accept special characters. While you try to enter special characters, either it should not accept or it should give some error messages. So in this way, you can design positive and negative test scenarios for a password login password system. Okay. So, with a more elaborative example, this is explained. Suppose you are doing the testing on a login form, which is has the following fields. That login form: username, password, sign in, sign up, cancel, login button, etc. Now, the positive scenario of login form is that you enter the valid username, the valid password in the username and password field. Then you can click on the login button to check whether the user is able to log in or not. If it is able to log in, it is passed. Okay. Then you say that, okay, the positive test case has passed. The one of the negative scenario is that the negative testing scenario of the login form is that suppose you leave the password field blank, only you enter the username field and leave the password field blank, then click on the login button. If you are entering still you are able to log in, that means some problem in your system. Without password also you are able to log in, and if you are not able to log in, then that is correct. So negative scenario of login form is that you leave the password field blank and fill the username field only, and then click on the login button to check whether the user is able to log in or not. So this is an example of negative testing or negative scenario of login form. Okay. So consideration for both the testing. In both the testing, that means in both the positive testing and negative testing, the following factors needs to be need to be considered. You have to consider the input data, you have to consider the output result, as well as you have to consider the action which needs to be performed. So the testing techniques that can be used for positive and negative testing. What testing techniques you can use? You can use these boundary value analysis and equivalence partition testing that we have already seen earlier. You can read yourself. So this is the boundary value analysis. Boundary value analysis we have known, we have studied already earlier. So now in the boundary, if the input data is used within the boundary value, then it is said to be positive testing. If the input data it lies outside the boundary limits, then it is said to be negative testing. Okay. Suppose you are considering a system that can accept numbers from 0 to 10, then all other numbers are invalid values. Under this boundary value technique, the boundary values could be what? 0 to 2 means 0, 10, and one value may be less than 0, that is up to -10. Another you can take 10 to maybe 20, that will be also there. So in this case, I have taken positive values in between 0 to 10, positive testing. Less than 0, it is negative testing. Greater than 10 also, it will be also negative testing. Okay, because these are invalid values. Similarly, equivalence partitioning you have already known earlier, we will not discuss here. Here the partitions with valid values are used for positive testing, while partitions with invalid values they are used for negative testing. Like this, again the same value, maybe what you can say 0 to 10. So this is 0 to 10. Any number between 0 to 10 will be positive testing. Any number between 0 to -10 can be negative testing. For example, you can take 5 as positive value, valid value, -5 as negative value. Similarly, if you take any number between 10 to 20, that will be also negative testing, because in equivalence partitioning there will be one when the range is there, one will be valid test case, and two on the both the sides should be what invalid test cases that you have already known while we have taught you the equivalence class partitioning testing method. So these are few differences. I have already told you positive testing, negative testing. These are easy things. Please read yourself, and please remember that in positive testing, if you will design sufficient number of test cases, you can achieve 100% coverage in positive testing. But negative testing is so vast, unlimited, you cannot achieve 100% coverage. Negative testing requires a high degree of creativity among the testers to cover as many unknown as possible to avoid failure at a customer site. You have to use your experience, try to design as many number of test cases to make your system foolproof using negative testing. So small example of positive testing and negative testing are shown here. Okay, these are few of the distinctions between positive and negative testing. These are easy. Please read yourself. So I will take only 3-4 minutes on error guessing. So suppose we have told you so many black box testing techniques, isn't it? So starting from equivalence partitioning, boundary value to orthogonality testing, positive testing, negative testing, cause effect testing, decision table based testing, state table based testing, many black box testing techniques I have told you. So now suppose all the testing techniques failed. You are not able to test your system. The last option we can go for error guessing. You guess the error. Error guessing is the preferred method which is used when all other methods fail. Sometimes error guessing it is used to test some special cases. Error guessing is a very practical case wherein the tester uses what? He has to use his own intuition. He has to use his intuition, own experience, knowledge of project, bug history, and makes a guess about where the bug can be. Purely depends upon the tester. He has to use his experience because all the methods have failed. Now he has to use his own experience and knowledge, and he has to guess about where the bug can be. Basic idea is to make a list of possible errors in error-prone situations and then develop the test cases. You can make a list, you can make a checklist. The basic idea is to make a list of possible errors in the error-prone situations and then develop the test cases. No general procedure for this error guessing or for this technique exists. It is purely an ad hoc process. You have to use your own experience and knowledge. I will take only a small example. Suppose you have to find out the roots of a quadratic equation. We have to find out the special cases in the roots of a quadratic equation. So for example, what will happen when a is equal to 0 in the quadratic equation? That we have to test. Because those cases errors might arise. What will happen when a is equal to 0 in the quadratic equation? Though we do consider this case, okay? Though we do discuss, sometimes we may overlook this, we may overlook it while testing as it has two cases. What are the two cases? If a is equal to 0, what will happen then? It's a quadratic equation. Then the equation is no longer quadratic, isn't it? And you know what is a quadratic equation? X square plus bx plus c is equal to 0. So if a is equal to 0, then the equation is no longer quadratic. And for calculation of roots, while we will find out the root, for calculation of roots, the division is by 0. So we may overlook. So these are the cases we may overlook. As error guessing, you particularly find these cases. You target at these cases. You list these points. These points errors might occur. So accordingly, you make a checklist, include these points, and explicitly check these points. This is this testing can be done by using your previous knowledge, by using your experience. Similarly, other cases you may consider, what will happen when all inputs are negative? All inputs ABC, A square plus BX plus C. What will happen when all inputs are negative? Accordingly, design some test cases for that. What will happen when the input list is empty? No input. The user is a layman. He has not provided any input. What will happen when the input list is empty? That you would see. Accordingly, you design the test cases. So this is how, by guessing, by using your own knowledge and experience, you can guess where the error may lie. This is the process of error guessing. Okay. Today we have discussed the orthogonal. Last class we have discussed the orthogonal array testing. Today we have explained the positive and negative testing with suitable examples. We have also presented the concept of error guessing. Okay. Actually, this is references. It is not there in this. Only this OIT is there. Orthogonal array testing is available in chapter 4 of Naresh 1, and this positive negative test and this error guessing is also available in that Naresh 1 book. But this positive and negative testing I have taken from some internet sources. That is not available in this book. Some other books I have taken. I don't have that book or the internet reference right now. You can search from any book or from any other internet sources. Thank you very much. Any doubt, please? Those who are having classes, they may leave immediately. Otherwise, those who are having doubts can ask. Any doubt, please?